I want to introduce you to my metrics library. I'm going to start off, tell you a little bit about myself and why I bothered to do this. So I am an SRE at Planet Labs. We're right across the street hiring. I've actually never been an SRE before. All of my professional experience has been writing distributed systems and databases. But I wanted a change, and we had tens of petabytes, and they were running tens of thousands of machines on AWS. So it seemed like a pretty cool problem. There was a little bit of a metrics issue with all of the vendors we had tried. I was talking to some of the metrics people around here as well, and it sounds like people are starting to address the same things, where I don't want to call it any names, but all of the telemetry that I saw didn't really provide an accurate picture of the systems under stress. So that was really my initial motivation for the project. And also, the other motivation for the project is, as far as I can tell, and hopefully someone educates me afterwards of how I am wrong, there's actually no good metrics library for C. And then once I went down this path, I realized there are no good metrics libraries. So first of all, a little warning, I'm speaking for myself, not Planet. So all of this stuff is my opinions. So what is Rust metrics, what we're talking about? So to answer that question, I have to ask the question under it, which is, what are metrics? And then and actually the Rust metrics library also has this notion of events and alarms, but those words mean things to you, but probably not what they mean to me. What they really all kind of cover is this notion of a telemetry system. Now I've come up with a whole new word. What does telemetry mean? So I looked it up, and it's a Greek word, tele meaning remote, metry being measure. And actually I thought this picture, I don't know if you can see it, is probably the best explanation of telemetry I've ever seen. So this is some telemetry system we use to kill people. And basically that plane there is what they're trying to get information on, and you can see all those flight dynamics, and that's going to some person across the world. So you're taking information about this plane and around this plane and all over the plane, and you're shipping it to some dude who's going to help that fighter pilot kill more people. Now that we realize that telemetry isn't so much about measurement per se, as it is how those measurements are presented to people. And it's kind of a weird thing to get your mind around. So I do want to get a little bit more specific about telemetry. Actually, there's this definition that Google had for telemetry, which is I'm going to build off of. And it says that telemetry is an automated communication process by which measurements and other data, so measurements and other data, so what other data, what is that, are collected at remote or inaccessible points and transmitted to endpoints for monitoring. So my telemetry library, or metrics library, kind of breaks up its telemetry into two types of things. One of them are what are called metrics or measurements. So if you guys have seen the Coda Hail library, you've probably seen gauges, you've probably seen counters, you've probably seen a histogram, you might even seen some estimated moving average with like a meter abstraction. It's pretty common. We also have this notion of events. So if you look at most contemporary logging systems or telemetry systems, so let's take Kubernetes puts out two types of telemetry, and it groups it into these categories, what they call metrics, and then it pushes out these things that are called events. So what are some things that we push at Planet Labs to our event systems currently? So a good example of something that we push to an event is every time a database backup is complete, every time you deploy your code, every time you Docker push, really any logging of a certain threshold ends up hitting someone's face somewhere. And actually, in the Rust telemetry world, we kind of blend these two. So metrics can become alarms. And the way that a metric can become alarmed is you can do kind of the boring old school thresholding, but we also just alarm when the metric gets too low or too high. So if it's, the standard deviation is on one side of the curve, the other, it's an alarm by default if you don't tune it. So also these metrics have a name. This is pretty normal for metrics. Events do not have a name. And we also, now because of contemporary telemetry libraries, have an optional map of strings to strings so that you can label any of your metrics, although not all of the libraries that we use support it. I'm sorry if this is still a little abstract. I promise to make this more concrete as we go forward. So this is kind of a history of telemetry library, or alerting systems in my professional career. And I kind of broke this up into the top being what I would call viable, and the bottom being really off limits to production systems. So I remember working in the finance world, and I was telling the admin guys about Nagios, and they'd be like, no, you don't understand. We don't use that open source stuff here. There was actually like a culture that open source was just bad, even at that point, for anything that you were doing serious. And since we were serious people, we just built our own alarming system. I think a lot of people had this experience. I think a lot of people are comfortable using Nagios nowadays, but they were comfortable buying Splunk as soon as that came out in 2003. So that was kind of viable for these kind of production workloads. And I don't know when it happened, roughly around the same time Google was doing their work with telemetry, which is sometime after the creation of Splunk, that we really started to see open source actually hidden here. But what you can see here is, Nagios, which was kind of state of the art in '99, really what's happening is you're just running a script. That script's going to return 0 or 1. So this script has really no context except for the environment that it's running in. By 2003, Splunk had realized that it was insufficient and that alarming on this kind of isolated view of the data is just going to bug the hell out of people. Like, I don't know if you guys have seen any of the big metrics manifestos, but in general, at least where I work, if an alarm makes it to a human face, there should be something that they could do with that alarm. Like if someone's actually looking at an alarm, like it should be alarming, and they should do something about it. When an alarm hits you, you should reach your Zen state and become perfectly calm. Roughly around 2010-ish, with Sumo and that, we started seeing people are just outsourcing their telemetry. You see this now with all paper trails and all these types of things. And actually, I want to cover Google's work here in the meantime, because if you look at the talks that they've given in Monotorama, they iterated through 3 or 4 different telemetry and logging systems, and they all kind of had this same vibe, where you would kind of have like low levels of aggregation, and aggregation would kind of work its way up. So you'd have kind of system level collection, and then that would work its way up into a rack, and then you would kind of aggregate results off a rack, and then you would kind of aggregate higher and higher, and it sucks, and it can never actually get it to work at scale. This is actually like, when you actually start writing the math behind this, you realize how hard this problem really is if you want a complete view of things. And they've kind of gone back and forth in terms of like push-based systems or pull-based systems, and we did try to learn those lessons. I actually am embarrassed to say I worked on the Hadoop project, and we also attempted to learn lessons before Google wrote their papers on kind of abstract talks and stuff on systems we didn't really understand, and I'm really embarrassed to say I'm doing that again. But I didn't totally rip them off. I think we have improved it. And finally, in 2016, I think we're starting to see the turn back. So people still want to ship some set of their data to a third-party vendor for DR and that type of stuff. But especially for what we're doing, like I said, we have tens of thousands of machines. It would be very expensive to get the level of telemetry we need in a third-party vendor. Like I said, we've gone through kind of all of them, and there's no real way that we can have 20,000 machines, signaling every couple seconds or even every tens of seconds for all that they're doing. So we're starting to see it move back. There's a vendor called Log Mountain, which is a kind of an interesting hybrid, which makes it really easy to run like logging on your own cloud, and it's all open source and stuff like that. And I'm trying to put Rust metrics in that same bailiwick of, yeah, we think about SaaS, we know we have to export to SaaS, but we also want to give people the capability to do everything on-prem. that one is not really a replacement for the other. So getting into Rust metrics, I was trying to figure out the best way to explain it, and this was the the best way I could come up with. Hopefully people have written computer programs here before. But this is it. This is really the core. I mean, there's some other stuff around here, but I quickly want to go through the components of this system. I promise to make it painless. Actually, quick show of hands, just so I know, how many people here have heard of Coda Hale's metrics libraries? Okay, cool. So a couple people have seen that type of thing. For y'all, you'll notice that those metrics kind of line up the same as the Coda Hale libraries. What's different than the Coda Hale implementations for those metrics is, one, we did some pretty fancy smart stuff with the Rust code. So these metrics are send and sync, which means they can not only be moved across threads, but they can actually be copied across threads. So this is actually tricky because underneath the code, I have to detect whether or not you're copying across threads, and then provide interior mutability through a mutex, if that makes any sense. Or in some cases, it meant developing these things using atomic instructions. There's no histogram listed there. That's because there's actually a third-party library for the histogram. There is a histogram in this code. But we actually exposed its API through wrapping it through our metrics interface. But roughly, metrics are either meters, counters, gauges, histograms with a name and an optional set of labels of string to string. And then there's all the reporters. So currently, we put out to Carbon, which is graphite. Your console emit puts out to Elasticsearch, influx, syslog, direct-to-journal D, and we also have a Prometheus library. And then also you notice there's this thing called the static reporter, which should probably be called the the multi-reporter. And the idea behind a static reporter is it's literally a static variable in your code which contains all of your reporters and handles all the thresholding logic between them. And I'll get into what that looks like because it's a little bit tricky. You also notice that there's a pretty small alarming library, so we have a notion of alarms and some estimated move average code, but that's really it, right? So you have things which report metrics up, you have metrics, and you have some place to collect metrics. That's pretty much it. So this is where things get weird. I'm really sorry for my handwriting, y'all. I'm on call right now, so I did not get to convert these slides into pretty pictures, so I hope this makes sense. But this is an example. This is like a weird example. I wanted to kind of provide an example to show you the power of the techniques that I made here. So who here has heard of Kubernetes? Cool. Yeah, so when I say Kates, that's K and then 8 letters and then S for Kubernetes. I think that's pretty generally accepted. And Kubernetes has this notion of a pod, right? If you know about Kubernetes, you know that the pod is the fundamental level of abstraction. And the thing about these pods is they're not, they're one-to-one, they're generally one-to-one with machines. They're not one-to-one with machines. You can have many pods on a single machine, but you can have many containers in a pod. So in our theoretical pod here, we have a container. That container application has the Rust metrics library. That's what the RM is supposed to be. But there's also another application running on the machine that also has the Rust metrics library. And so these two things are interfering with each other, right? Like you can imagine you have ATA API events. You could have a hardware, like a more severe hardware failure, any malfunction, or even, let's say, not even malfunctions, right? Like if these containers are using a volume disk and the application is using those same volume disks, that's actually really important for understanding whether or not your application is performing as it should. So, so this is really rough, right? Going back to the Nagios world, your Nagios script is maybe running in that container, or maybe it's running in the application, or maybe you're really crazy and you have to run it on the host machine as root, because that's the only way to get into your containers. Well, I don't know, the notion of running my Nagios scripts as root scares the dickens out of me, so I'm not going to do that. So, I don't know, here's a weird one. How many people have heard of the C4 model? This is something in my head. I don't know, so basically when I try to do system design, I generally think of it in terms of these levels of aggregation. So you have kind of at the lowest level, you have code. That code or class can make up some component. So you could imagine like a component maybe like something in a thread or something like that. And then inside of that you have a container. That doesn't mean a Docker container. It could be a Docker container. It could be a JVM or even arguably with a virtual machine. And then you kind of have this global context, right? So when you think of your distributed application, right, you might have one bit which is like receiving Twitter data and another one which, and the problem is that you actually need to correlate all of this across all of these machines to actually perfectly have a global view of all of your data. So that's impossible, right? Like we can't send all of the data in our code up to our contexts. There's some workloads that are notorious for not working well with sampling. There's all sorts of fancy statistical techniques we can do to get better and better sampling. But this is actually a big focus for me is actually one of the reporters that we have is really about this aggregation story. And we actually took the same failed approach, at least on this version, that Google has used in their earlier versions, where we're just like writing out the CSVs, aggregating those CSVs, pushing them up. Right? That's the kind of simple reporter model we have right now, and that'll at least get you all the way to pass somewhere between the container and context view, and then we're really relying on systems like Prometheus or SignalFX to give us that last level of context, but we also have Rust metrics can be run as a standalone reporter to provide that level of aggregation or context. Cool. So as I said, we're not really a push or a pull model. So what does that mean? I want to kind of define that. So if you look at traditional systems like syslog or graphite, the program emits some information and it is sent to some third-party system. And the problem with these systems traditionally is it means, I don't know how many of you guys have had to ops in our syslog server, but if you point like thousands of machines at an R syslog server, what you get is kind of a random dispersion of logs, because our syslog can't handle thousands of machines all talking to it. So you have to build some level of hierarchy, and it does its own aggregation and all these things. But in essence, like you can have like a serious thundering herd problem. Most systems don't have any way of accounting for that. So contemporary monitoring systems like Prometheus, based off of the experience that Google had at the time, have opted for a more pull model where there's some capability for alarming in the application. Interestingly enough, Google has gone away from pull model, and they now say that it's fully hybrid. Actually, sounds pretty similar to what I built here. Some of the things that we do push is we actually push randomly. I didn't put it in there. There's actually some code that I'm writing right now to force thundering herd problems before your application goes live, so that way you can actually know if you're going to be pushing and knocking things over. We push when the traffic gets really, really low, and we push when the traffic gets really, really high, which means that the static reporter library might have to keep some type of statistics of the biggest or smallest metrics it's seen. But this is like simple memoization, right? Like we're not keeping data, we're keeping like histograms or thresholds on data. Finally, we do have this kind of separate notion of alarms. We're trying to really build that out. I say we, but this is like me and a couple open source people. I don't want you to think that this is like a huge group of people. Finally, as I pointed out before, metrics themselves can be configured to alert out. So a good example of a non-metric alarm would be it's really easy to push, a syslog error level, error level threshold through this as an alarm if you don't want to have to build that library yourself, although generally there's good support in most languages. Wow, it says I've been talking for 55 minutes, which seems unlikely. I'll say it's been 20. I want to leave the end of this for questions, and I actually need some help. So just to quickly describe what this is actually the one that I'm using now. So basically, in our application suite, we kind of have an example of this multi-reporter kind of pushing out everywhere. So you've got your Rust metrics cog. It's constantly storing stuff in Prometheus, and it's keeping kind of a rolling window of metrics. It's sending cluster level or host level events like my hard drive failed to Elasticsearch because That, as far as I can tell, is what I'm supposed to use for Kubernetes and AWS, or maybe InfluxDB. I don't know. Is Philip here? Said he was here. Okay. No, we don't have the Influx people. We actually, in this case, I had some legacy Carbon systems, so there's one metric that's still going to graphite. And then there's actually some information specifically, purposely done through standard out and standard that's going through the Docker journal D interface. And then yet another interface to syslog, where I'm using an ancient library called Spade to do basic anomaly detection. And this is all in a library that's pretty tiny. So this is all written in Rust. You can kind of choose which one of these libraries you want at compile time. Since we do have Prometheus, that does mean that this particular library was compiled with support for an HTTP server and protocol buffers. We are looking at a new Prometheus reported to the text interface, so that way we don't have to have a full-fledged protobuf library in there. But you can see that this is like super crazy, right? Like, one would never get into this situation, hopefully, but it's pretty normal to do something like Prometheus and syslog, right? So you kind of keep your telemetry in Prometheus, waiting for it to be scraped by the Prometheus server, but if a threshold reaches a new high or a new low, that's probably useful information to actually push. And then that has to be done in a way that, in our case at Planet, would scale to tens of thousands of nodes. I also don't want to, even though my company was inspired me to write this, I don't want you to think that I'm saying that we use it in production. I cannot tell you what I use in production. So that's mostly it. What are the big next steps? Number 3 is the main reason why I'm talking about this in public, because it is not, like I said, something we want to support in production. I really want some C hackers to help me build out the C API. Our Rust API is getting better with the support of the Rust community very quickly, fancy macros and all that stuff. We'd like the same thing with the C API. The reality is that the people who I trust to help me in the C land are so surly that their advice is not yet useful. So hopefully, if I can get less surly advice from C program, that would be good. Master is currently not production. We just took a new committer in, and I have done a bad job at mentoring him and let some bad stuff in. But we will make sure the README gets updated soon as I fix that. And finally, the aggregation support. Right now we're just doing basic CSV. We've got some super cool magic that should be way better, that won't involve processing huge amounts of data. I think Google was talking about when they did their CSV aggregation, they were spending, this is some talk a couple of years ago, they were talking about, spending upwards of 10% of the system overhead just aggregating data, and I don't think that's where we want to be. So with that, my attempt at making a short talk is over.